Flutter for beginners for backend developers. Introduction. Flutter is Google's cross-platform UI framework used to build mobile, web, desktop, and embedded applications using Dart. Backend developers often learn Flutter to build mobile apps, create front-end UIs, become full-stack developers, integrate with Spring Boot APIs, develop Android and iOS apps from one codebase. A common learning topic is, how can backend developers learn Flutter quickly? This guide explains Flutter basics, Dart fundamentals, Flutter architecture, widgets, state management, API integration, Flutter plus Spring Boot integration, navigation, debugging, deployment, best practices. This is one of the best beginner guides for backend developers moving into mobile development. Simple definition. Flutter is a UI framework for building cross-platform applications using Dart. Why backend developers learn Flutter? Backend developers already understand Save, APIs, databases, authentication, application architecture, business logic. Flutter helps backend developers build Android apps, iOS apps, admin dashboards, front-end clients for APIs. Flutter architecture overview. Typical architecture. Flutter UI, state management, REST API calls, Spring Boot backend, PostgreSQL database. Flutter versus traditional mobile development. Traditional Flutter, separate Android and iOS apps, single codebase, Kotlin plus Swift, Dart only, multiple teams, unified development, more maintenance, faster development. Step 1. Install Flutter. Official tools needed. Flutter SDK, Android Studio or VS Code, Android SDK, Xcode, macOS for iOS. Check installation. Flutter Doctor. This verifies SDK installation, emulator setup, dependencies. Step 2. Understand Dart basics. Flutter uses Dart. Dart is similar to Java. Java example. Public class user, private string name. Dart equivalent, class user, string name, user, this name. Step 3. Create first Flutter app. Create project. Flutter create my app. Run app. Flutter run. Project structure. lib Android iOS, pubspec.yaml. Step 4. Understand widgets. Everything in Flutter is a widget. Examples. Text, text buttons, images, layouts, screens. Example. Text, hello Flutter. Step 5. Stateless versus stateful widgets. Very important Flutter concept. Stateless widget. Static UI. Example. Class welcome text extends stateless widget. Override, widget build context, return text, welcome. No changing state. Stateful widget, dynamic UI. Example, class counter page extends stateful widget. Override, state counter page, create state, equals counter page state. Used for counters, forms, API data, dynamic UI updates. Step 6. Understand build method. The build method creates UI. Example. Override, widget build context, return scaffold, body center, child text, hello. Step 7. Learn common widgets. Widget purpose, text display text, container layout wrapper, row horizontal layout, column vertical layout, list view, scrollable list, scaffold, app structure, app bar, top navigation bar. 8. Build layouts. Example. Column, children, text, name, text, email, equivalent to, vertical layout. Step 9. Handle button clicks. Example. Elevated button, on pressed, print, clicked. Child, text, login. Update UI dynamically. Example. Set state. Counter plus plus. This rebuilds UI. Step 11. Learn navigation. Navigate between screens. Example. Navigator.push, context, material page route, builder context, homepage, inline. Step 12, handle user input. Text input example. Text field, controller, used for login forms, search, registration. Step 13, call REST APIs. Backend developers already know APIs. Flutter commonly uses :HTTP package, :DO package. Example, final response equals await HTTP get, URI.parse, HTTPS, API.example.com, users. Backend APIs return JSON. Example, ID, 1, name, John, Flutter model, class, user, final int ID, final string name, user, required this.id, required this.name, factory user.fromJSON, map string dynamic JSON, return user, ID JSON ID, name JSON name. Step 15. Connect Flutter with Spring Boot. Typical architecture. Flutter app, Spring Boot REST API, PostgreSQL. Authentication flow. Flutter login, Spring Boot JWT API, JWT token returned. Step 16. Store authentication tokens. Popular storage. Shared preferences, secure storage, best practice. Store JWT securely. Step 17. Learn state management. Very important interview topic. Popular options. Tool usage provider, beginner-friendly Riverpod, modern scalable block, enterprise architecture, GetX, lightweight provider example, class, counter provider, extends change notifier, int, counter, equals, 0. Void, increment, counter plus plus, notify listeners. H8. Understand async await. Flutter uses async programming heavily. Example, future void, load users, async, final response, equals await API service, .get users. Equivalent to Java async concepts. Step 19. Handle errors. Example, try, catch E, print E. Common issues. Key, API failures, JSON parsing, null errors, network timeout. Step 20. Learn Flutter debugging. Useful tools. Check Flutter Dev Tools, check Debug Print, check Breakpoints, Widget Inspector. Run DevTools. Flutter Pub Global Activate DevTools. Step 21. Understand Hot Reload. Very important Flutter feature. Hot Reload. Clack. Updates UI instantly. Keeps app state. Shortcut. Save file means UI updates immediately. Benefits. Faster development. Step 22. Learn Flutter project structure. Recommended structure. lib/models, screens, services, providers, widgets, utils. Benefits. Scalability, maintainability. Step 23. Build reusable widgets. Example, class custom button extends stateless widget. Benefits. UI, cleaner code. Step 24. Understand Flutter deployment. Deploy Android. Flutter build APK. Deploy iOS. Flutter build iOS. Step 25. Learn common Flutter packages. Popular packages. Package purpose. HTTP API calls, DO advanced networking provider, state management, Go router, navigation, Firebase core, Firebase shared preferences, local storage, real-world example, social media app architecture, Flutter mobile app, values Spring Boot backend, PostgreSQL, Redis cache features. Login, profile management, image upload, notifications, infinite scroll, JWT authentication, Flutter responsibilities. UI rendering, API calls, token handling, navigation, state management, backend responsibilities. Check authentication. Check business logic. Check database operations. Media storage. Check APIs. Common beginner mistakes. 1. Putting everything in one file creates messy projects. 2. Ignoring state management. UI becomes difficult to maintain. 3. Blocking UI thread. Heavy work freezes UI. 4. Poor API error handling. Apps crash unexpectedly. 5. Rebuilding too many widgets. Performance problems appear. Best practices. Separate UI and business logic. Use proper state management. Organize folders cleanly. Reuse widgets. Validate API responses. Secure JWT storage. Handle loading states. Optimize rebuilds. Test on real devices. Use responsive layouts. Common interview questions. 1. What is Flutter? Flutter is Google's cross-platform UI framework for building mobile, web, and desktop apps. 2. What is a widget? Widgets are the building blocks of Flutter UI. 3. Difference between stateless and stateful widgets. Type, behavior, stateless static UI, stateful dynamic UI. 4. Why use provider or block? They help manage application state cleanly. 5. How does Flutter communicate with backend APIs? Using HTTP requests and JSON APIs. Flutter plus Spring Boot system design. Flutter mobile app, API gateway, Spring Boot microservices, PostgreSQL, Redis. Flutter versus React Native. Feature, Flutter, React Native. Dart, JavaScript. Rendering, Native Engine, Native Bridge. Performance, excellent, good. UI consistency, strong, depends on platform. Final summary. Flutter is an excellent framework for backend developers entering front-end and mobile development. Important concepts include widgets, state management, navigation, REST APIs, JSON parsing, async programming, Flutter architecture, deployment. Backend developers already understand APIs, authentication, architecture, scalability, making Flutter easier to learn. Key idea. Flutter allows backend developers to become full-stack mobile developers using a single cross-platform codebase integrated with modern backend APIs.